Hi, this is Ben McCone with Technically Speaking at Source Allies. Today we're going to be talking about some foundations of functional programming and two keystone features that really need to be kept in mind when you are approaching a problem in a functional way. These two methods are immutability and first-class functions. Let's dive in. First, let's look at immutability. What is immutability? Immutability simply means when we are changing a program, we're changing data, we favor creating new pieces of data rather than modifying existing structures like an array. In each example, we will be looking at an example of something that is non-functional, and then something that is functional, and at the end, we'll tie everything together. So first, non-functional approach to immutability. In this example, we are simply writing a function to append an item to an array. These examples are written in TypeScript, but could very quickly be converted to JavaScript as well. Starting from the top, this function simply does one thing. It calls array.push, which is a pretty standard way to add to an array, but may not be favorable. As we can see down below, when this is run, every time append item is called, it's modifying that existing array. And this is a downside because if this were a third-party dependency, we don't necessarily expect these third-party dependencies to change our data, and this can be the cause of bugs in many programs. Let's take a look at how this may be done in a functional way. In functional programming, it looks very similar, but instead of calling array.push, we are spreading the array into a new array, and then we are appending item on the end of this. Now, let's go ahead and run this program and see what that really looks like. So you'll see we log that array initially. It has the values 1, 2, and 3. We call append item with the value of 4, but when we log that, 4 is not in that result. The reason is that we created new state. Array is immutable. So down below on line 11, we store the result of append item into updated array with the value of 5. When that is then logged out, we see the value is now 1, 2, 3, 5. Again, this is very important because as we're changing data, it can be very easy to modify an existing array to cause many problems and not realize it until the bugs have been found in production. Let's go ahead and close this example, and we will move on over to our second example, which is first-class functions. Now, what a first-class function means is that functions can be used as variables. Said another way, this gives us the ability to pass functions as arguments to other functions. In the non-functional method, we have a function say twice. It doesn't take any arguments. It has a hard dependency. It is tightly coupled to this function say hello, and say hello just simply console logs hello world. Let's again clear, and we will run this example, and we see it does just what we would expect. It says hello world twice. Now, you may look at this code, and yes, it's a little bit cluttered, but it may not look that bad at first glance. The challenge is if we ever have any other data or any other function that we want to run twice, we now need to write the original function, and we need to write its analog to run it twice. Or we simply just need to call that method twice. Now, in a functional paradigm, what we would do is we would write a higher order function called twice. Twice receives a callable. This is simply another way to say it receives a function, and that function is expected to return nothing. This function then just simply again calls that callable twice. We have the same say hello function down below, and we just call in twice say hello. Let's go ahead and again run this just like so, and everything works as we would expect. But as I had alluded to earlier, we now have the ability to do other things. Console.log goodbye. And when we run this again, now that twice function has been able to be reused again and again anytime we have a function that needs to be called twice. This is where first-class functions are extremely helpful to the idea of functional programming. Now, let's tie it all together with a third example. In JavaScript, we may not need to call a function twice. We may not need to append items to an array in these ways. But what we may need to do is create a data pipeline that takes in data, in this case, an array of numbers, filters out everything that is not even, and then doubles the numbers that remain. So in a traditional non-functional paradigm, what we may see is a function double even numbers. We create a new number array in that function, and then we loop over every item in the numbers array that was passed in. If the number at that index is even, then we simply push that result times 2, and we'll see if we run this, 3 altogether, non-functional, that doesn't work. Aha! We forgot to return new numbers. Let's go ahead again, clear that, and run it again. And we see that we just have the one value, 2, that was then doubled and returns an array of a single value, 4. Now, if we were to add another piece of data, say a number 4, we would run this again. We would expect two values, a 4 and an 8, because both the 2 and the 4 were doubled, and the 1 and the 3 were filtered out or were not included. This is fine in this simple example, but quickly as we are building data pipelines to really filter out, map, and change data in large arrays of objects, this can become unruly very quickly. So that's where the functional approach, in JavaScript, this is done by calling map, filter, or reduce on an existing array. And we'll be covering filter and map in this example. So what we see, we have our same array, and instead of writing a function at all, we simply call array.filter, give us any data that number mod 2 is 0. This gives us any value that is even, and then map the resulting array and multiply every array by itself. In this example, this is actually squared, not doubled. Let's go ahead and change that. Doubled, num times 2. And again, we will go ahead and clear, and then run that example. 3 altogether, functional, and we see again, we have that single value 4 because we only have one value that is even in this example. And then that value is then doubled to 4. Just as we did in the previous example, let's add 4, and we'll see that we get now 4 and 8. These are just some examples on why functional programming is so important as we are working with large data sets, because it is much easier to read .filter, .map than it is to read this large loop that simply adds items to a new array and returns them. While we may not be mutating that existing array, this is still hard to read because we have to read the entirety of the loop to understand what's going on, whereas in the functional approach, we can view each piece individually and say .filter, okay, this removes all of the non-even or all of the odd elements. And then we can read map again in isolation and says, this doubles every item in that array. This has been Ben McCone with Technically Speaking at Source Allies. Today we covered some of the principles of functional programming, including immutability and first-class functions. Have another topic you'd like to see covered? Comment down below. Check us out at sourceallies.com. Thank you for watching, and we'll see you next time.